Hi guys, today I'll be telling you how do you make a end-to-end CI/CD pipeline and a Docker containers as well as Docker image and compose file for your project. And the project is multi-instance calculation on EC2. So the first EC2 instance will take input output, second will do addition, third subtraction, fourth multiplication, fifth division, and the sixth EC2 instance will take all the data from your EC2 instance first and will transfer it to your DynamoDB table. So everything we are gonna do from Terraform. So let's see how do we create a Terraform. So this is a script for Terraform in which I have added the code previously. So this is, I'll let you know, explain you the code. So firstly, we need to provide a AWS region or AWS uh, that we are doing or we want to create the resources on AWS. So the provider is AWS and the region in which I want to create all the resources is UST1. So yeah, the first thing is what I'm making is AWS instance. Which is the AWS instance? It's the instance one. So instance one is what we are creating as of now. The AMI ID is for the Linux. T2 micro is the instance type, and key is already I have created a key, or you could create a new key as per your choice. Is project. Now the security group which I have created is Launch Wizard 2. So it's the Launch Wizard 2. I'm attaching the security group and this key to every EC2 instance. So every EC2 instance will have same key pair, same security group, same VPC, and same subnet. So how will they all have same subnet is if we create a EC2 instance all together, then they all lie in the same subnet or same VPC. If you create a EC2 instance one by one, then the subnets and VPC, everything gets changes. Now we are creating all the EC2 instances one by one. So in tags, I've written name instance one. Now, this is the user data that you don't have to do anything on this, and you'll just let it commented out just for your understanding. I've added it. Now, in the similar way, we are gonna create an instance two. Now, in instance two, what the instance two was doing is it was adding the two numbers. So instead of writing the script of adding two numbers after launching the issue instance, I've added those that script to user data. Now in this, you could see I have added this code in user data. What it will do is it will install the Python pip library and install Flask in it. Why Flask we are installing is because here we are transferring all the data and everything we are launching and doing everything from sending requests to taking requests using Flask. So here is nothing. You could see the data that he is taking from the instance one. So num1 is the input number one, num2 is the input number two, result is num1 plus num2. So this is the result that is gonna send it to back to your EC2 instance one. Now instance three. Now how are you gonna do this instance three? Everything remains same, launch user 2, T2 micro, AMI ID. Now what you're gonna do is instance three is subtracting num1 from num2. So the script remains same. You install your dependencies before, and then once you install the dependencies, the result is num1 minus num2, and you send it back to your EC2 instance one. And the port in which we are running this is 5000. So that has to be mentioned in every instance. So then AMI ID for Linux, T2 micro, instance type for instance 4. And then in instance 4, the result will be num1 into num4, num2. Then instance 5 would be for the division of them. So this is how you're gonna create 5 instances. Now in instance 6, what it is gonna do is it is gonna take the data from instance 1 and send it to your DynamoDB table. Now how it is sending is firstly let's create a EC2 instance, then everything remains same, but in the data, user data, how you're gonna take the uh, EC2 data from EC2 instance one is firstly you're gonna import the Boto3, which is like a Python library, and how you're gonna import is uh, you also see we have also created a DynamoDB table by the name of calculation results. Now name calculation results billing is pay per request. How much we are gonna do, how much we are gonna use, we are gonna pay for that much, and the key is operation ID. How we are gonna partition the table. Now everything remains default. Now how you're gonna do the code for EC2 instance 6 is you're gonna create a table here. You could see uh, in this we are gonna table dot put underscore item is we have created a table in which we are going to put the item. So first is operation ID, how we are going to separate the table. Second is the first row would be num1, then num2, then addition, subtraction, multiplication, division. Now, after that, the result of all those things will be converted into string because the table in which we have created the DynamoDB table, it is in string format. Yeah, so it is going to take the data, store of the data of num1, num2, then the result from EC2 instance 1, fetch the data from EC2 instance 1 from of subtraction, then here is fetching the data for multiplication, and here it is fetching the data for division. And yeah, at the end, it is gonna tell us the message that our data has been saved to DynamoDB successfully. You could change it to anything else that as per you want. And yeah, so this is our uh, table for sorry, Terraform code for how to create 6 EC2 instances and one DynamoDB table. Earlier we were creating it manually, now we are creating it using this Terraform code. Now, once you have created this, you just need to save this code. And this is, I already have created a GitHub library. I'll show you GitHub, in which this is my, wait. I'll show you my library for this. This is my GitHub repo. And in this, I've already created and cloned it on here. So now I have added nothing here, you could see. Now I'll add this main.tf file in my GitHub repo. And before that, I also will tell you how do you create a Terraform file or CI/CD file. I'll just comment this out first. Okay. Or let's just do it before only. So now that you have created this main.tf file, now, what you have to do is you have to create a CI/CD pipeline, a YAML script to run your CI/CD pipeline. Now, what that YAML script is do is what you all will do, what you all were doing manually is what we have to write in that YAML file so that the process gets automated. So, let's name it Terraform CI/CD on push in main branch. What it means is whenever you push anything in main branch, everything or the CI/CD pipeline gets activated and it's run. So, you could also write this workflow dispatch. What it means is you can also manually run the CI/CD pipeline by going to your GitHub repo. Now, what's the job is? Firstly, where it is running is it is running on Ubuntu, latest Ubuntu, whichever it is gonna be there, it will run on that. Now, what are the steps? Firstly, it is gonna check out code. What it is gonna do is it is gonna check out the code, whatever you have written line by line. Then you have to install the Terraform provider, which is there. So setting up Terraform is the second step. So here I have added Terraform version. What it means is you could write any Terraform version in which you want your code to be. Then how do you now? The first thing when you were not doing it with GitHub, you used to write here access key and secret key. Now, right now, there is no access key right now that you have provided because you can't write access keys in your code. So that is why I have already added my access keys here. You could see you go to settings, you go to your secret action key. Now here I have already added your AWS access key ID and secret key ID. You could go to your new repository secret and add your own access keys. After that, let's just go to this Terraform. Now after this, initialize Terraform. Now how do you initialize this? Terraform init is the code to initialize your Terraform ID. Now after that, Terraform FMT, what it does is, if you have your anywhere you have your code written in unclear format, so it just format your code in a with proper indentation. After that, what it does is Terraform validate. It checks your code for any errors that is being provided with you. And then what you have to do is you just have to run your code accordingly. So Terraform plan, what it does is whatever you have written in your code, that whatever resources you want your Terraform to create, it gives you a planned structure of that. Now here you could see I have created a AWS access key ID. What it does is AWS access key ID is taking the you need to know, you need to like specify in which AWS region or in which AWS account, you want to create all these resources. So AWS access key ID is fetching it from secrets. You could see a secrets.aws.access key ID. So by this name, we have saved it in our secrets, and you could access it by using the syntax secrets.access key ID. And then same is with secret key ID. So once you have taken this, now you could uh, uh, like run the code for Terraform plan in your uh, like CI/CD pipeline. Once this is done, you could see you could have to once you get the planned things of whatever resources you want to create, you could just go for like take the access key and secret key ID and perform the code Terraform plan. Terraform apply. Now auto approve means is once you apply a Terraform apply, then he asks you for approval and you have to write yes or no. So auto approve means that we have already approved and you could directly go ahead with creating the resources. Now what this destroys thing is, now this is like a optional thing. You could even remove it from your code if you want. So what it does is Terraform destroy. Now, if you have a work, if you like have created your resources on your Terraform and now you want to delete your resources, then you have to again go back to your AWS and delete everything manually. What it does is now this destroy thing is what it is doing is it is working on workflow dispatch. What workflow dispatch means it will allow you to right now when you push your code, this step will get skipped. I'll show you how it's getting skipped. But if you once you have created the resources and you want to delete your CI/CD pipeline or stop your CI/CD pipeline, you could just destroy the resources by rerunning this your CI/CD pipeline and skipping this part and running this part only. Then that is what you could do. Now, how it is that how that you're doing is using your workflow dispatch thing to run that. Now, yes, now we'll just save this and as well as our main.tf file. So this is your resources file, Terraform file, main Terraform file. This is your CI/CD script. Now, once you have saved this, you could go to your GitHub and push those. And you could write like added uh, Terraform code and CI/CD flow, and you'll commit it. And once you push it, I'll show you. We have saved it. Once you push this, now you have pushed it, and you could see added Terraform code and CI/CD flow. Let's go to your GitHub and let's go to your actions in this, and you could see this is the CI/CD pipeline that is running as of now. Now let's just wait for it to completely run, and then we'll just till then just go to our console. Go to our EC2. Now go to our instances. I'm just showing you how those instances are creating. Right now you could see no matching instance, no running instance are there. Now let's just wait for this pipeline to complete. It's completed. Now you could see Terraform plan and apply. It is right now on the Terraform plan and apply stage. Now, if the pipeline doesn't work completely, a cross sign would be there. If it works from like exactly how you want it to, then a tick sign would be there. Let's see. Let's wait for it to complete. It's completed. Uh, okay. Till then, just go back to our code and just go. Let's once this CI/CD pipeline works, then you have to like perform again the steps that you usually perform on EC2 instance one. Now, now you could see the pipeline is currently working completely. You could see this is working. Now, what is this is you could go to Terraform destroy the job was skipped. How it is getting skipped is because once you go and do everything and you have the in your code, I'll show you. Yeah, this workflow dispatch. What it means is it is right now skipping that part in which you have written this workflow dispatch and it will activate that part once you rerun your CI/CD pipeline. Now this is done. Now let's just go back to our instances. uh, refresh those. Now you could see a instance 1, 2, 3, 4, 5, 6. Now these are your instances. Now once you are here, now you could just have to like go back to your page or the folder in which now I have opened the terminal. Now you have to SSH into your first EC2 instance, or I'll show you that. Uh, this is the command to SSH. Now let's just SSH into our first EC2 instance. Now let's SSH into a second first. Now this is the public IP for your second EC2 instance. You could copy it from here, go to the terminal and paste it. Now you enter it. Now you are entering your second EC2 instance. Now we have saved a file in our code. I'll show you. Now in our main, in the second EC2 instance, we have saved a file by the name of where it is instance2.py. This is what you have saved your file as. I'll show you if that file is still there or not. So go back, you click clear. Now you click on ls. Now you could see your instance2.py file is there. You could even go inside your file nano2.py, and here you could see your file. Now once you've seen your file, now let's just run this Blast server. Let's just go to how will you run is Python 3 instance your file name pnc instance2.py the end symbol. This is how you are gonna run your file. Okay, wait, no such file. Instance. Okay, so this is how you're gonna. This is like warning. This is a development server running all addresses. Now this is running. Now let's just go and minimize this. Let's just create another window and let's go SSH again. We'll do SSH. Now let's do SSH on a third instance. What it was doing is it was just subtracting our two numbers. Now going to a third instance, copying the IPv4 address and pasting it here. This is the command. This is like the key pair is in my downloads folder and EC2 user the public IP of that EC2 instance. Now we are entering in a third EC2 instance. In this, just clear, or I'll show you in our code. You could see in our third EC2 instance, we have created a file name as instance3.py. Now, instance3.py, let's just clear it from here and ls. Now you could see our instance3.py. Let's just run this file again. Let's just run the Flask server again in this instance3.py. This is how you're gonna run your Flask server on your EC2 instance 3. Now this is also running. Let's just go to our fourth instance. Now we'll again SSH into our fourth instance. Uh, let's just see our IP address of our fourth instance. Now this is the IP address for our fourth instance. Just copy this and paste it here. Now you could see we are entering in our fourth EC2 instance. In this we have saved a file as, let's see if it still is there or not, instance4.py. Let's just go here, do ls. You could see the file is there, instance4.py. Now let's just run the Flask server in this also, instance4.py. And yes, now the instance 4 is also running. Now once you run your instance 4, let's just we have 6 EC2 instances, so we have to SSH into each to run the Flask server on each EC2 instances. Could see now instance 5. This is our instance 5. Let's just copy the code, just paste it here. and just enter our, now we are entering our fifth EC2 instance. Now the file which we have saved here was, now EC2 instance 5. The file name was instance5.py. So let's just see if it's still there or not. Just clear the screen, ls. Now you could see instance5.py is there. So let's just run the Flask server on this EC2 instance, Python 5, Python 3 instance 5.py, and this is how you run your EC2 Flask, uh, Python Flask on your EC2 fifth server. Now the sixth is still there. Now let's just copy our IPv4 address. Let's just go and run our sixth EC2 instance. Let's SSH and just SSH into our sixth EC2 instance. Now, once you enter, you'll see yes, you have entered in your sixth. Now you could see in our sixth EC2 instance, we have created a file where save data, save underscore data.py. So let's just see like ls. You could see save underscore data. So again, run your Flask server in this also, so that I could perform the function Python 3 save underscore data.py. This is how you run the Flask server. Now it's running. Now what we have to do is let's just test everything. How you're gonna test this? Now you just go to your first EC2 instance. Just copy the IPv4 address and SSH into our first EC2 instance. This is how we're gonna do it. Copy and paste. Your Do your SSH into your first EC2 instance. Just clear. Now, if you want to know what we have done is, you could see the code in your first EC2 instance, you haven't added any user script. And why is that? Is because if you add your user script while creating your instance, or if you create a file while creating your EC2 instance, you cannot add those files after the EC2 instance is created. You can create any other file, but then those files are not editable. So it's the reason I wanna create your EC2 instance. I haven't added any user data. Now let's just install all the dependencies in this EC2 instance. Sudo yum update. Then let's just update everything, whatever there is. Okay, now everything is updated. Now see sudo, let's install our pip library. Sudo yum install Python 3 pip. Now it's gonna, yes. Now it is installing a pip library. Now we are gonna install our Flask. Pip3 install Flask. Okay, the spelling was wrong. Install Flask. Now it's gonna install our Flask server. Now let's just, everything is installed. Now you could see ls, there is no file. Let's just create a file and no instance one.py. Now we have created a file. Now you could see the first in our first EC2 instance, you could see that we have to like write the code to fetch everything and fetch data from other instances. So here is what you're gonna do. So this is the code for your fetching of instances. How it is working is, firstly, forwarding everything to your EC2 instance 6. Now, how we are fetching or how we are sending everything is, we are sending it over a using HTTP request. Now, for the HTTP request, what you need is you need the URL of every instance to whichever instance you wanna send or receive request from. So to save the data, we want the data to be saved in 6th EC2 instance. So here we'll write the URL of 6th EC2 instance. Let's just copy the URL of our 6th EC2 instance. Just paste it here. Now this is what what this is. This is the complete URL of a 6 EC2 instance, and you could see after that we have added port 5000 because we want to run this on port 5000. Now slash save is what I have done is if you I have given a shortcut for everything. Slash save means it is saving the data. Now after that there is the main function in which I have taken a user input of enter the first number and second number. After that, we are gonna send these data to our other EC2 instances. For addition, we want our EC2 instance second to work. So EC2 instance to copy the URL and paste it. Now this is the URL for a addition or subtraction. What that URL is doing is it is sending your HTTP request to each server. Now each server for or each EC2 instance. So what once it will send the HTTP request to every EC2 instance, it will just create a uh, addition subtraction and fetching the result via HTTP request only. Now this is the fourth EC2 instance which is gonna multiply our numbers and now EC2 instance 5. Now this is the EC2 instance which is gonna divide our number. So now this is how we have added our URL for each instances like slash add slash subtract multiply divide. What it is doing is it is just fetching your result or fetching your numbers, two numbers from first instance and sending the result to back again to your EC2 instance one. And then how we want to print our result is addition result, then the result of the EC2 instance which is fetch. Then same is with subtract, multiply, divide. And then after everything is there, we forward all the results to our EC2 instance 6. How we are going to forward it? uh, you could see we have created a function forward to instance 6. In that method, we send the argument num1, num2, and all the result. And then in the sixth EC2 instance, it will create a table. Let's just save this file and let's just exit from here. Now all the other servers are running, so we just need to run this server. So Python 3 instance 1.py. Now enter the first number. Now we have run a server. Now we'll enter the first number as 10. Now enter the second number. What we are taking the second number as 3. So once we press enter, every EC2 instance is gonna fetch the result these two numbers and send the result via HTTP request using Flask. Now I press enter and you could see addition result 13, subtraction 7, multiplication 30, and division is 3.33. And in the sixth EC2 instance, we have saved this data is saved to DynamoDB successfully. Now this is our of that our project is successfully running. Now let's just cross check and go to our DynamoDB to check if the table is actually created or not. Let's just go to our DynamoDB. We'll go to the tables. You could see there's this calculation result is already there. Now let's just export table items. Now you could see right now that table is created. Now this is the table of that addition, division, multiplication, num1, num2. Now you could see this table, operation ID is this, addition is this, division, multiplication, num1, num2, subtraction results. This is how you'll create your uh, everything that you want your EC2 instances and addition, subtraction, or how your EC2 instances are doing. Now what you're gonna do is let's go back to your code. Now you have now every time you commit everything, the CI/CD pipeline again starts. Now after that, what you have to do is now for your Docker file. Now what you have to do is you have to create a Docker file for each EC2 instance for the smooth like Docker orchestration. What it means is once you create a Docker containers, you want your Docker containers to run smoothly, and each week will create a Docker container for each instance and will create a Docker compose file. What it means is once we run that compose file, each container will run under a same network and they can easily interact with each other. Now, how do we do is let's just create a Python. Let's just write the Python code for each instance, like Docker file for each instance. And in that Docker file, we'll write the Python code. So firstly, let's go to here, just this, let's just enter instance one dot py. What it will do is in this, let's just make one more instance two dot py. What we'll do is in instance one, we'll write our Python code to add two numbers. Now in this, let's just copy this, just go add this. This is our instance one, and it is gonna add two numbers. Same is what you could make with uh your all the six instances. You could write the code, and here I have already written the code here so that it won't take long. Now I just paste those here, paste. Now we're gonna paste it here and under this. Now we have paste our. Now see, you could see I've done nothing but I have added all the code of all the things that are there. Now instance 2 will add two numbers. The result is adding two numbers. Instance 3 is subtracting. Instance 4 is multiplying. 5 is just gonna divide the two number. And in the sixth instance, we are storing all the things in our EC2 instance. Now you wanna create a Docker file for each instance. How you're gonna create the Docker file is Docker file dot instance one. This is how you're gonna create a Docker file for. Oh, okay. I was creating it at the wrong location. So in this, I'll create a Docker file dot instance one. This is how I'll create a Docker file for instance one. And similarly, you'll have to create a Docker file for each instance. I'll show you. Wait. Now, in those Docker files, I'll tell you how do you do or how do you. Now, in your first Docker file, you just have to write nothing from what it means is uh, which library do we have to install. So right now we are working on Python. So from Python. So this is the Python image that it is gonna pull from your Docker app. Now, how you're gonna let's create a working directory by the name of app. So a work directory slash app means we are gonna creating a working directory. In that we are creating a folder by the name of app. Now let's install all the dependencies. Run. Run is gonna, what it is gonna do is it is gonna install all the dependencies that we are there. So run pip install Flask. What it means is no cache directory. What it means is this code will just run the command pip install Flask. It is gonna install our Flask, and then whatever you have written in your instance one in this. Let's just delete. We have So in this, whatever you have written, all the things, all the code you have written, it will copy from instance one to your this app, which this app app is your folder name. Then you are running it on 5000 port, so expose 5000 mean just run it on your 5000 port. And what after that you want to do is how you were running your code in your Terraform is Python 3, then the file name. In this, you have to run it as Python instance one dot cmd means whatever you put inside cmd will itself run after everything else is composed. Now, once all these things gets completed, once everything gets completed, now it is gonna perform this thing. What it means is it means that you're running the code as Python instance one dot py. This is the code that is gonna run after this. What CMD means it is It means just this. Now this same is with Docker too. You install the Python, you create a you import your Python image, you create a app folder, and then in that you just install run pip install Flask. This is what you're gonna install. Then you're gonna copy all the things which you have written for the code. Then you copy all the code to this folder. Then then you run it on 5000 port, and then TMD is what it means is it is gonna run your Python instance 2.py. This file is what it is gonna run. Same as with 3. You could just see Python 3 is nothing but you just change the file name. Same as with 4. Same as with 5. Now you're just doing nothing but just doing the same thing on every Docker image. Once you do all of these things, now you wanna create a Docker compose file. Now how do you create a Docker compose file is now let's just uh Now, this is Docker compose file. Now, what it is it is just a YAML script so that which handles all the Docker images which you have created. It will handle all the images, run all the Docker containers in a single through a single file and under the same network. What it means is that your each container is independent on its own, but can interact with each other. Now, what are the services that it is doing is, for instance, one build context. What it is doing it is doing nothing, but it is just running your Docker container one. You just have to there's nothing that you're doing in your Docker compose file. Whatever you're doing is you're just entering the name of your Docker container. For here you have written your container Docker file one dot instance one. It is gonna run this image on the port 5001 on the port 5000. 5001 means base of the port is 5000. Then instance 2, what it is doing is it is running your Docker image for your instance 2 and for your instance 3, and same is all with all your instances. You just have to make a file in which you run all those instances simultaneously. Now once you have done this, you just save it, and now how do you run it is you just go to terminal. Just go to your terminal, and once you're on your terminal under this folder, you see the only command that you need is docker com compose up. What it means is it is gonna run all the containers and it is gonna run all the containers under a compose file. Now you press enter and you could see there's a warning sign that uh, all the version and everything will be ignored. Now it is gonna ask us if you wanna allow composing or building this container. We're gonna allow, and you could see here instance one, instance two, instance three, four, five, six. Everything is running. Every now you could see here we have uh, built 6 images for each instance. Then after that we have created a network by the name of multi-instance calculation. Then under that network, on the same network, all the 6 containers are running. You could see here, this is how the containers are running. Now, once those containers are running, you could see, uh, you could go on your Docker desktop app. You could see under here, these are all the containers or all the Docker images. You go on your images. These are the images that you just created. And now if you want to like send your image or need someone else to use your image, you could just send them this image, and then everything that they require will automatically get installed in that, because in our image or in our Docker script, we have written everything, how every dependency that is there has to be installed. So this is how you'll create your Docker orchestration and how you will run your Docker and build your Docker images, run your Docker container, everything, make your Docker compose file and run it on the same network. Now if you want to exit all from this, you have to create a new terminal under the same thing. We just go to a new terminal and simply write docker compose down. This is the command to just dis like close everything. It is gonna stop everything and also remove all the things that are there. You could wait. You could see here right now, everything is removed and stopped. So now you can write anything you want here. But clear, you go back to your Docker. You could see everything is stopped. Now it's nothing is working. Go to your containers, there's nothing. Every container is deleted. Now, yeah, so this is how you will create your CI/CD pipeline and Docker images for your multi-instance calculation app.